Okay, let's take a look at 93 restore IP addresses. So for this problem, actually I have already recorded one video before. However, for that video, I did not use stringbuilder, so the runtime is a little bit high. So for this video, I would challenge myself to use string builders instead of substrings. So yeah, I think this one is definitely as better than not using string builder. Okay, so I will just review our basic concepts about the valid IP address. Okay, in case you didn't see the last video that I made for 93 restore IP addresses. If you are interested in, you can go to check the video that I put the link at the bottom of the here. You can check it. Okay, let's see. What is the valid IP address? So let's take a look at here. First, the valid IP address has 4 parts. Okay, so one part. They are splitted by the dot. Okay, and the second is the length of the IP address. So for each part, we can, at a minimum, for each part at a minimum we can have at least 1 digit. Okay, digit. And the maximum digit that we can have for each part is 3 digits. Okay, so the total number of the digits that we can have is from 4 to 12. Okay, right? Because each part, if we have at most 3, 3, 3, 3, it's going to be 12, right? Okay, so if we have 1, 1, 1, 1, that's going to be 4 digits, right? Okay, another thing is you need to know is that if we have a digit which is 0, for example, like this, 0, 0, 0, 0, that works. It is a valid IP address. However, if your IP address is this, that's not a valid IP address, okay? Because if you have more than 1 digit in each part, you cannot have 0 at the beginning of the part. Okay, clear? So yeah, that's the basic concept, the definition of a valid IP address. Okay, next, what algorithm are we going to use? So for this problem, we're going to use DFS backtracking. Okay, so how do we use the DFS backtracking algorithm? I will show you. Let's draw a recursion tree. You will get a basic understanding of how the DFS backtracking works for this problem. Let's see, we have this example, right? As we said, we have 4 parts. Let's see, part 1, part 2, part 3, part 4. You can see that's our recursion levels, right? And for part 1, we have 3 choices. The first choice is we can choose 1 digit. The second choice is we can choose 2 digits. And the third choice is we can choose 3 digits, right? Okay, for our part 2, we have same choices. We can choose 1 digit, or 2 digits, or 3 digits. Okay, so for here, 552. 552 is another thing that we need to abandon, is because for the maximum 3 digits, we cannot be bigger than 255, which means it must be smaller than 255, smaller or equal than 255, okay? Yeah, let's continue. See part 3. If we choose part 1 for 1 digit, choose another digit for second part, and we'll continue the 3 choices. We can have 5 here, and 2 choices, and 3 choices, 3 digits, right? Continue 2 and 25 or 255. Okay, let's make this more clear for you. So for this choice, we have 3 choices, right? And for this single choice, we have 3 choices, right? And for this 5, we have another choices. It's going to be 2, 25, 255. Okay, let's take a look at this path. It's 2552, right? 2552. Well, we have 4 parts. However, it is not valid IP address. Why? It is because that we only use the first 4 digits in the string S. For this problem, we need to use all of the digits to make a valid IP address. Okay? So apparently, we only have 2 valid IP address, which is 255, the first choice 255, we choose 3 digits, and then for the second part, we choose 3 digits. For the third part, we choose either 2 or 3 digits. And for the fourth part, we choose either 3 or 2 parts. Okay, so if we find out this path doesn't work, we just go back to the backtracking and to check, oh, if at the end of part we choose 2 digits, does it work? If it's not working, we just go back to here and go to this choice and see, oh, if we can choose 1 or 2 or 3 for the fourth part. So that's how our DFS backtracking works. I hope you get a basic understanding about the algorithm. Okay? Yeah. Now let's coding. As I said, I'm going to use stringbuilder to finish this DFS backtracking because it saves time, a lot of time. Okay, stringbuilder. Let's be new stringbuilder. Okay, let's do a base case check. If our S is none or S down length smaller than 4 or S down length is bigger than 12, just return result, right? Okay, here we just do DFS and return result. We're going to fill this part later. Let's focus on the DFS main part. Let's see, we're going to pass our strings to here, string builders. And we have 4 parts, right? We have parts, and we have an index to let us know which part of the string that we're traversing. Okay, and finally we put our result here. So now we can fill this part. As a string builder, part 0, index 0, and result. Okay, nice. Let's do base case check. So when do we stop our recursion? Okay, I think we already know when the part equals 4 and when we use all the digits in the string, right? So the index equals less than length. And here we add our string builder and then return. Okay, now let's focus this part. So we have 3 choices, right? Case 1, choose 1 digit. Case 2, 2 digits, right? And case 3, we have 3 digits, right? Okay, so that's the choices we have. So why not we just iterate them? 1 smaller or equal than 3 and I plus plus. Okay, So we're going to iterate the string based on the index that we have. While we iterate string, we're going to use the index to record where we are right now. Okay. So first one we're going to choose 1, second 2 or 3, and 3 digits. Okay. So let's write this part. If the index plus I bigger than s than length, what do? We just break, right? Because it's too big, our index is out of the boundary. So we just break it. And then if then we're going to get a string. We call it value, okay, val, and it is a substring of s, right? So start from index and end at index plus I. For example, for the first part, and we start from index 0 and then end at 0 plus 1. So we just use 1 digit for our part 1, right? Okay, so for the part 1, if our val, the length bigger than 1, and val starts with 0, what do? We break, right? Because it's invalid. Then value of, and another thing is that if the val's value is bigger or equal than 256, it's not valid. Neither. We break it. Okay, nice. For here, we record the string builder's length because later we are going to delete either 3 of the string builder or 2 or 1, right? So we need to have a variable to record the string builder's length. Okay. So if the index equals 0, it means that we're at the beginning part of or at the head of the each part, right? So what do? String builder just append the val because we don't need to append the here, right? If the index is not 0, we need to append this first and the val later. Oops. Okay, cool. Next, we just do DFS. We recurse to the next level. So we have S, SB, our part need to plus 1, our index should be plus I, result. Finally, should delete the part that we added. Length plus I plus 1. Okay. For example, if we want to delete the 1 digit, right? So the length is just 1, and a 1 plus let's see here, right? 1 plus 1 and a plus 1. Why we plus 1 here? It is because we have a dot there, so we need to delete all of them. Yeah. Okay, so we finish all the coding part. Be careful for these details here. Let's check if there's any errors that I made. Okay, so run the code. Okay, it is accepted and we submit it. Nice. Okay, thank you for watching.